Hello guys, welcome to this class. Here we'll be looking at one of the method we use to solve second order differential equation, and the method is called the Allenbart theory. Here you get some call it the Lambert, but I call it the Allenbart theory. Are you with me? Or the Allenbart method of solving second order differential equation. Now, I know one thing you ask yourself is how do you identify this question first on this particular type of method of solving second order differential equation? And also, after identifying how do we solve, we've been working on second order differential equation, and we started with homogeneous second order equation whereby we solved. From there, we moved into inhomogeneous and we talked about different method. But here, should in case you are given second order differential equation question and you've been given a solution, for example, given this second order differential equation, you are told that the x is equal to exponential y is equal to exponential 2x is a solution. Since you've been given one part of the solution, then you're asked to find the mini solution or the general solution to the particular question. Then you use what? The Allenbart theory. Now look at the screen. The screen says that the Allenbart method with one given solution. You'll be given what? One solution. Since you have one solution, it falls on the Allenbart method of solving second order differential equation. Okay, so with that, we should be able to identify questions that falls on what? This method. Now, since we know how to identify, now let's see how do we solve question, how do we break it down. Okay, now let's go by the definition or by the note on our screen. Suppose y is equal to u. We are given u, where u is one of the solution of a second order differential equation. Okay, let's assume this is the second order differential equation. Let's call it equation 1. This equation 1 is the equation, and you are given y to be equal to u to be one of the solution. By the Allenbart method, the general solution may be found by substituting y to be equal to what? The u given and a of x. So what we are trying to say is, since we are told that the first solution or one of the solution is u, now by Allenbart, you do what? The general solution is y is equal to the u that you are given multiply with what? A of x, where u and a are function of what? Ax. Now, since we want to use this method, we assume that since y is equal to u of x, the one you are given, we assume that it satisfied the equation, which is pu prime prime plus qu prime plus ru to be equal to what? Is 0. Are you with me? Now, how do we solve? Since we are agreeing, since we believe that our general solution is y is equal to u of x and then a of x, okay, we can decide to take the first derivative of this. If you are to take the first derivative of this, then y prime will be u of x, a prime of x plus u prime of x, a of x. Okay, that's product rule. Okay, now let's find the second derivative. The second derivative, which is y prime prime, will be u prime of x, a prime prime of x plus u prime of x, a prime of x. So I apply the product rule on this to have this, plus now let's apply product rule on this. That's u prime of x, a prime of x plus u prime prime of x, a prime of x. Okay, so at that point I've been able to apply what? I've been able to apply product rule on that, which I can now say that y prime prime is the same thing as u of x, a prime prime of x plus what is the same thing as this? That's 2 u prime of x, a prime of x plus u prime prime of x, a prime of x. Now at this point we can substitute our y prime prime and y prime with our y into our what? Our original equation. By substituting that into it, I can now say my original equation is now the same thing as p of the first derivative. Are you with me? So I can just go straight to the point by saying it is p u. Okay, let's just take it one after the other. By substituting this into it, I can say it's the same thing as p u p into bracket u a prime prime plus 2u prime a prime plus u prime prime a prime, close the bracket, plus our q into bracket, what's the first order derivative? That's u a prime plus u prime a, close the bracket, plus arg of y, that's arg into bracket, what is my y? U a is equal to what? Is 0. Okay, so if we are to factorize this, I can say that okay, let's try to open the bracket. If you open the bracket, I have it to be p u a prime prime plus 2 pu prime a prime plus pu prime prime a prime plus q into au a prime u plus qu prime a plus ru a equal to 0. Now I'm trying to like factorize. Let's factorize the a out. So I can say that okay, I'm having a prime here, a prime prime here. Let me pick the a prime prime out. So I only have this to be a prime prime. So I can say a prime prime into bracket pu plus now a prime. This is a prime. This is a prime. This is a prime. Those are the three a prime. So I can say a prime into bracket pu prime prime plus qu prime plus ru. Okay, that's for I've made a mistake, sorry. Let me clean it. Now let's pick it again. For the prime prime, this is the first one, this is the second one, so I can say that that's 2 pu prime plus qu plus qu, you get that? Plus qu. Hope I did not make mistake. Okay, so okay, plus now let's pick the one of ordinary a. Now ordinary a, this is ordinary a, this is ordinary a. Is that all? Yeah, ordinary a. I think I have one more ordinary a. Let's check. Okay, yeah, it's correct. Wait, this one, this is it here. This one, this is it. Qu for a prime, this is it. Then I'm left with this and this. Okay, this should be ordinary a. How come did I get that should be a mistake from my side? So I can review it. This pu prime prime is ordinary a. Sorry about that. Okay, so let's just continue. So that will give us pu prime prime plus qu prime plus ru. This is how we derive the method of solving. So that's what we are trying to look into. Show you get is equal to 0. But don't forget, we said look at this. We said since this is a solution, then this is confirmed to be our equation solution. So I can say that both pu prime prime plus qu prime plus ru is equal to 0. Since that is equal to 0, which means that this part is what? Is 0. Since this part is equal to 0, I'll be left with what? I'll be left with this and this, which is the same thing as a prime of 2pu prime plus qu, okay, plus a prime prime of pu is equal to 0. So at this point we say let z to be equal to what? A prime. And if z is equal to a prime, therefore z prime will be equal to what? A prime prime. So at this point, if you are to substitute, that will be giving us pu a prime prime, that's what? Z prime plus into bracket 2pu prime plus qu z is equal to 0. Now at this point, your equation will be what? At this point, once you get to this point, it means your second order differential equation will be reduced to what? Either linear equation or any first order differential equation that will be very easy to what? To solve. After that, you keep on solving. When you keep on solving until you arrive at an answer for what? A, because we said our general solution will be what? Y is equal to UA, and you'll be given the value for U because the question says a solution have been provided, which is U. Now the second solution is A. So on getting to this part, you integrate, you break it down until you have an answer for what? For A. So all this one is just what? Definition, so that if you are taking our examples, you'll be able to understand the steps or why we are doing it like that. The definitions might look confusing, but still let's try to look into example. So I believe with the help of the example, you'll be able to understand what the definition is saying. Okay, now let's look into one example. Okay, let's take this perfect example. The question says that simplify or solve. Look at the example. The example says that solve the equation y prime prime minus 4xy prime plus into bracket 4x squared minus 2y equals to 0, given that y is equal to exponential x squared to be a solution. Now, when given y to be equal to exponential x squared to be a solution, and you're asked to solve this question, the fact that you've been given a solution out of the solution, it shows that it is what? The Allenbart method. Now, to solve this, I believe the one given is what? U. Then I'll have to look for what? A. So I can say my general solution is the same thing as y of UA. Are you with me? And since my general solution is y of UA, I can say that that's y is equal to, what is my u? That will be AU. What is my u? U is exponential x squared. Okay, now let's try to differentiate what is here. If I differentiate this, I have y prime to be equal to, product through, write the first one, that's u, differentiate the second one, that's 2x exponential x squared, plus write the second one, differentiate the first one, that's a prime exponential x squared. That's our what? First derivative. Confirm. Now if we are to find the second derivative is y prime prime, but you have to be very, very careful. At this point, this 2x is a function, this a is a function, this exponential is a function. That's product rule of three different functions. And to solve that, using the formula UVW prime plus UV prime W plus U prime VW, that's what? Product rule for three given function. So to simplify this, I'll be using what? This formula. Therefore, I can say that y prime prime is equal to 2x a. Now differentiate the third one, that will give us 2x exponential x squared, okay, plus u 2x, differentiate a prime exponential x squared, plus differentiate 2x 2, write your VA, write your W exponential x squared. So we've differentiated this part. Now let's go to the second one, which is this. Now to differentiate this, that's what product rule. And product rule says that write the first one a prime, differentiate the second one, that's 2x exponential x squared, plus write the second one exponential x squared, differentiate the first one, that's a prime prime. Okay, so that's our what? That's our second derivative. Now at this point, I have my y, I have my y prime, I have my y prime prime. I can substitute it into the what? Into the question. So putting it into the question, my question will now be what? Y prime prime first, which is the same thing as everything that is there. Now let's write it out. This is 4x squared a exponential x squared plus 2x a prime exponential x squared plus 2a exponential x squared plus 2x a prime exponential x squared plus a prime prime exponential x squared. That's the what? That's the first what's it called? That's the first this thing, the y prime prime. Now plus, okay, sorry, minus 4x into bracket y prime. Y prime is 2x a exponential x squared plus a prime exponential x squared. Okay, now the constant part, that's plus into bracket 4x squared minus 2y. What is the value for y? Y is a exponential x squared, okay, which is equal to what? Is 0. Now let's see, let's try to simplify that. So I can say that is the same thing as this is it, 4x squared a exponential x squared, okay, or better still, let me write it in the order of the degree of a. Let's start with this one. Let me just strike it out once it's being written. Let me strike it out with my red pen. No, let me use this pen. So writing this one first, I have it to be a prime prime exponential x squared. Okay, now let me write the ax. Okay, that's the first one. Now let's pick this. I have it to be plus 4x squared a exponential x squared. Now I want to write this, but I notice what is here is the same thing as what is there, so I can add it together to give me plus 4x a prime exponential x squared. So I've written this. Now I'm left with this one alone for the aspect of y prime, that's plus 2a exponential x squared. So I've written the y prime prime. Now for the y prime, I'm going to what? Open the bracket with minus 4x, meaning minus 4x times what is there? That's minus 8x squared a exponential x squared minus 4x times what is there? That's minus 4x a prime exponential x squared. Okay, now let's open the bracket. This times this, that will give us plus 4x squared a exponential x squared minus 2 times this, that will give us minus 2a exponential x squared. All is equal to what? Is 0. Now at this point, I can say that if you look at it very well, I can say that what is here, okay, and what is here is the same thing. So 4 of this plus 4 of this give us 8 of it, which is also the same thing as this. So I have positive 8 and positive negative 8. So it means this will eliminate each other. Okay, it's going to what? Eliminate each other. Likewise, what is here is the same thing as what is here. So it means this and this will eliminate each other. Also, what is here is the same thing as this. This and this eliminate each other. So I'm left with what? I'm left with a prime exponential x squared is equal to what? Is 0. Okay, since it's equal to 0, then I can say that it is equal to what is 0. Accepted. Now at the end of everything, exponential a prime prime is equal to what is 0. Okay, but what is a prime prime? Recall that we said z is equal to a prime, therefore z prime is equal to a prime prime. So in replace of this a prime prime, I have it to be what? Z prime is equal to 0. And what is z prime? Z prime is the same thing as dz dx, right? That's what dz dx. Now at this point, I can say that dz dx is equal to what is 0, which I can say that dz is equal to 0. Let's integrate both sides. If I integrate both sides, I have it to be, if you integrate the z, you have it to be what? Z is equal to, if you integrate 0, it's still 0. But when you integrate both sides, you have to put your what? Your constant. So I can say plus c. This is my constant, c1. Okay, so if that is c1, but what is z itself? Z itself is what? A prime. Are you with me? No, we said let z be 8 prime. So in replace of this z, I can substitute my 8 prime. So my a prime is equal to the constant c1. If I integrate both sides, if I integrate 8 prime, I have to be what? Ordinary a. So if we integrate constant c, it's going to give us constant cx plus c2. You know now, when you integrate a constant, it's going to what? You are going to attach x to it, and when you integrate both sides, you still have to put plus c, arbitrary constant. So my a is equal to c1 x plus c2. Now go back to our solution. We said our general solution is what? Y is equal to the u of x you are given and the a of x you are looking for. And from the question, we are given that u of x, which is the first solution, is equal to what? Exponential x squared. Therefore, I can say my general solution, which is the same thing as y equals to u of x times a of x, is now the same thing as y is equal to, what is my u of x? Exponential x squared times, what is my a of x? That's c1x plus c2. Okay, so I can say my final answer is exponential x squared into bracket c1x plus c2 equals to y. Final answer. So that's what we call the Allenby method, giving one solution of second order differential equation. We'll be looking at another example in our next video so that you'll be able to understand the concept very well. Thank you. Should in case you have any question, feel free to ask me on our Telegram platform. Thank you.